Welcome back. And what was the topics that we are going to cover in this entire session? Okay, so this session is everyone knows about this, but any which ways, I'm just going through the thing. So now, what we are going to cover in this sessions. First of all, welcome all to Terraform, Docker, Kubernetes, and Jenkins sessions. So I will simply call them as continuous deployment tools. So these are the continuous deployment tools or delivery tools. Okay. Basically, whenever we are doing a SDLC lifecycle, we will be using the CI/CD pipelines and CI/CD configurations. Before I go into the technicalities, okay, so let me introduce about myself. So I am Chaitanya. I'm having 13 years of experience into the IT industry. So I started my career as a system engineer and then I worked as a system administrator. Currently, I'm working as a DevSecOps engineer in an MNC company. So that's my job role. And then when you come to my technicality training experience, so from 2013 onwards, I am into the training field. I train the students on Microsoft products like Microsoft servers, and then I train the candidates on Cisco, CCNA, and then I train my candidates on the AWS and DevOps, and as well as the Azure. So these are my training training platforms which I have trained my students. And then when you come to my certification, I am a certified Kubernetes administrator, and as well as I am a certified AWS engineer. So I have my AWS certification like developer certification and as well as associate level developer, associate level what I can say, and then DevOps professional. So these are the certifications that I'm having right in the AWS environment. So that is about my introduction. Okay. So now when we come back to this concept of Terraform and Docker and Kubernetes, before we go into the concept, so what is your knowledge on this? So how well you know about these tools? Do you have any idea about Docker Kubernetes, or else this is the first time? So why you want to do this course? So can you please tell me about yourself so that we can go into the topic? At least a minimum 5 members. Yeah.
Yes, then Harsh this side.
Yeah, Harsh.
Like I am into or like product support. So
Mhm.
sometimes there are requirement of uh, uh, like Kubernetes stuff. Like there are some issues where customer is having using the Kubernetes environment. So as well as some CI/CD tools like Jenkins or Bitbucket Cloud. So just want to level up myself.
Okay, cool. So previously, what is your work culture like? Previously, what is your position? Right now, what is your position?
Like I'm into there is a backup product, so
Mhm.
I'm into support, troubleshooting customer cases, onboarding customers on
Okay,
the on this backup product.
good, good. Okay, thank you. Yep.
Good morning, Chaitanya. This is Lawal.
Hello, right?
Yeah, so I'm working as a Linux engineer,
Mm-hmm.
but I want to same like I want to move to the DevOps engineer, but I still I don't have opportunity to work on Docker and Kubernetes, so I
Okay,
wanted to learn and I wanted to move on.
good, good. Okay, cool. Yes, any other? Kamal, Ben, I know you.
Yeah, I didn't know.
Yeah, hi, Nilesh.
Yeah, yeah, I just joined this batch to develop and upskill from my because earlier I have worked on this DevOps project, but
Mm-hmm.
in terms of technology, I worked on the light speed and harness. Okay, but
Okay.
I am trying to make this. So right now, the
Mm-hmm.
demanding things are. like Terraform, Docker, in every as well as even from the cloud perspective, AWS as well. Okay, so
Yeah.
from my end, I'm just showing this. Yeah, thanks.
Good, good. Good.
Hi, Chaitanya. This is
Hi,
Kamal.
yeah, come on.
Yeah. I work on Microsoft products. I've been an dev and architect for a while on Azure services.
Mm-hmm.
But I've done Docker a little bit, but not much. I've done mostly on app services and AI, Gen AI.
Mm-hmm.
My customers do work on AKS and ACA. So I wanted to learn the basics and kind of I can try and slice and work on learn a period of a month. So once
Okay.
I know the basics, I think the AKS
Mm-hmm.
using the AKS would be easier. That's my
Cool,
goal.
cool. Okay. So yeah, so I will get the introduction from all the other whenever the time being is there. Thank you for your introductions. So now let me go into the concept of what is this Terraform, Docker, Kubernetes, and Jenkins package? What is this current package? What we are discussing? Okay. What is this course?
Chaitanya,
Okay. Yeah.
can I ask a quick question?
Yeah.
I
Go on.
use biceps and does it like Azure DevOps or GitHub?
Mhm.
With this course, it'll be easier for me to learn the other like those tools as well, right? Or
Yeah.
is there a different course for it?
1 second. So can you come again once again?
When you use Azure services, it's biceps and ARM templates are more
I,
closer,
I, I
right?
understand that Azure
Yeah.
Bicep you are talking about. I know about that. It's an infrastructure as a code. So yeah, go on.
So with Terraform, would it be easier for me to like kind of relate and
See,
associate with biceps as
that's
well?
that's something different. Terraform is an infrastructure as a code, and Azure Biceps is also an infrastructure. Microsoft deliverable infrastructure as a code itself. Okay, it's a declarative language for defining the infrastructure as a code. But we will not working on the Azure here. Okay, but understanding the Terraform will help you to go into that platform also. Okay, I'm not saying that you won't be able to do that, but it has a different kind of language that we are using. For example, if you see ARM templates, we will be working on a different types of different language perspective. And when you come to the Terraform, we will be writing the code in a different language. So there might be a little bit difference will be there, but eventually you can do that. Okay, finally. The point is the way how you are working on that. So if you have the knowledge on that, resource creation or else infrastructure as a code, then you can work it out, no problem. Okay, you got the answer for your question, or still you have the confusion?
No, thank you. I kind of typed it. Thank you.
So what is this course for, and what is this course, and then why we are learning this course, why we are learning the course, and then what else, uh, what will be covered in this course? Okay, what will be covered in this course? Let's see that. First one is what is this course? So this course is completely of continuous delivery and continuous deployment tools. Okay, so we are missing Ansible over here. But if I include Ansible here, so then you will get the complete CD tools will be there. Okay, so if you see here, CI slash CD. So this is what we will call it as whenever we are doing any software deployment. Okay, so I will call it as SDLC, software deployment lifecycle. What you are going to learn First of all, in the software deployment lifecycle, there will be some tools related to whenever, for example, if you are having, there is an IT company. Okay, let me tell you in a story manner. So there is an IT company. So this IT company will provide the products to the end customers. Okay, or else will provide the products to the clients. Who will be the clients of an IT company? The end customers are not the clients. So there will be a non-IT company who is the client of this IT company. So for example, if I take it as a medical sector, hospitals, banking sector, or else entertainment, or else any another. Okay, so these non-IT people will be there. So they are the clients of this IT people. So now whenever they come and ask the IT, I mean, this company, they are saying that, so I want an application for my customers, whoever are the customers or else whoever are the clients that are there for this IT company. For example, if you take a bank, okay, so bank will have so many number of customers or clients. Okay, so they want to do the internet banking, they want to do the mobile banking. So in general, every customer is nowadays is having a one-touch solutions. Okay, they want one-touch solutions. Everyone are having their own smartphones. So this banking sector or the bank people will come to the IT company and request for an application to be developed. So now what this IT company will do here is, first of all, they will have a clear-cut meeting with all their CEO, CFO, and the bank people and the top level managers. Everyone are going to sit in that meeting and discuss about the requirements. So that is what the requirement gathering is all about. So when they do the requirement gathering and everyone are happy with the I mean IT company and as well as the but that banking company, everyone are happy with what is the work that we have done in the previous, and they are okay to give us the project. There will be biddings and everything will happen. So they are ready to give us the project. Now what will happen here is, so in the IT company we will have a developers. We will have the developers. So now what these developers will do, in developers you will have the UI UX team. UI means user interface, UX means user experience. So the team will be there. So they will be responsible for creating the front end, and there will be a back end team. So the back end team, either it might be a Java team or Python team, depending on the application requirement. So the people will be creating the back end. So if it is more working on the Java or more working on the Python, they will create. And inside this application, for example, we are creating a banking application. So this banking application requires so many number of microservices. Whatever the banking application that we are creating, this banking application will have user management microservice will be there. User management means user creation, that is user registration, user sign up. These are all comes under the user management. And then you will have the user dashboard also comes under the user management. Later, you will have the services like retail services and as well as corporate services. Retail services in the sense normal personal banking, corporate services in the sense the business banking. So, for example, if you want to get a salary, okay, so now that company needs to have an corporate account. So, for that corporate account, we will create another service, and then you will have the wallet services, okay, and then you will have the loan services. You will have the credit card and debit card services. Like that, you will be having so many different kinds of services that are included in that particular application. Now, each service is a microservice. Okay. Now, for example, this backend user management service can be created with the help of Java. So then the backend developers which we require is a Java developers. So I will divide like this. For example, this is created by Java. So we require the Java developers. For example, there is an retail banking application where the entire application can be created under the Java. And then you are having the corporate application. So this is also a Java microservice. So I will take it as a Java microservice only. Now, when you come to the wallet and loan microservices, these services will be created in .NET or Python. Then these are developed by another backend developers. So the Java developers cannot create this wallet and loan services. Every day you are using these applications. I don't need to say much more about these things. Now, what will happen here when they start working on this? They require the different kinds of backend people. So they will be assigning that team. So they will be assigning these microservices to that particular team. Now, when these microservices are assigned to that team, they will start working on creating the microservices. Now, once they started creating, they need to have a database so that there will be a database management team will be there. These are also comes under the development. Some people will call them under other operations also, but any which ways they will come under the development. So with the help of, for example, MySQL, PostgreSQL, so they will be using these kinds of database to store the data, or else Oracle, most reliable and most trustable database, Oracle or MySQL. And then MS SQL is there, Microsoft SQL database is there, and then you are having MongoDB is there. You can use MongoDB also. Like that, there are so many databases through which the engineers or the what I can say the developers can work with. So like that, what is happening? Everyone are working on this development perspective. When everyone are working on this developer, so this is fine. So this is what the developers will do. So these are all developers will be created under the project management software. They will be assigned with the project under the project management softwares. So what are the project management softwares that you know? So there are some Jira and Zoho. So there are some softwares that are available. With the help of this project management softwares, what they can do here is the users who are working on that project will be tied up with the project, and every day to day whatever the scrum calls are there, or else whatever the day-to-day activities that are doing, they will be updating everything into this project management softwares. Later, what will happen once the project, once they have updated the code, or else once they have came to know that in the project management, everything will be updated. We completed up to this particular level of task, or else we have fixed this bug. Everything will be updated in that project management. Now, once it is done, then what will happen here is in the development perspective, they start developing the application. They start understanding, analyzing the designing and what is the microservice architecture that should be there. So here you are hearing some new words, microservices. So whoever are working from the past 10 years or 15 years, they know about this, but any which is, it is a basic understanding to know about the microservices. Any which ways, we'll discuss about that. So now what is happening? This project management, once the project management, which means assigning of the project to a particular set of people is done, then they will start working on the code development. So now once the code is developed, then they are going to use the version control system, VCS, version control system, like Git, GitHub, or GitLab, Bitbucket. So this is a centralized version control system. Git is a local version control system. GitHub is the centralized version control system where they can store their code, and they can collaborate with the multiple developers. So many developers will be connected to that GitHub, and whatever the project they are doing on that, so they will be updating the code, they will be pushing and sending the pull request. So there are so many things that we can do with the GitHub. So now once this is done, so then what they are going to do? So before moving the code into the GitHub, they will be doing the unit testing also. Once they have written the code, okay, implementation is done. So in the first stage, requirements gathering from the client. The second stage is designing and assigning the project to the concerned developers. And the third stage is writing the implementation stage. Implementation stage, what they are going to do, they are going to write the code and do the unit testing. When they are doing the unit testing, everyone knows about this. So the developers has to do the unit testing. So it is not a responsibility of the testing people to do the unit testing. Developers has to do that. So when the developers are doing this unit testing, so they will understand how the code is working, what is the output that they are getting. So if the output is satisfactory, then they will push the code into this version control system, nothing but Git or GitHub. So once Git is a local version control system, and what I can say, GitHub is the centralized version control system. So locally we will use the Git to manage the entire code, and in the remote repository, if I want to push the entire code into the remote repository, then with the help of local Git, we will be pushing that into the centralized GitHub. So this is about these are the two tools, guys. So everyone will think that Git and GitHub both are the same, but Git is used in your local computer and GitHub is in the remote repository, remote version control system, where you can work with the what I can say. There are different concepts of GitHubs like pull request, and then you will be having what else I can say, tags will be there, version tags will be there. Like that, there are so many different kinds of things are there in the GitHub also. So now when we come to the once we have pushed the code into the GitHub, then we need to do the code quality analysis. Okay, code quality analysis. Okay, so this will be this will be done with the help of a tool called as SonarQube. So before SonarQube, previously there is senior developers will be there. They used to monitor the entire code. If there are any repetitions or else any problematic situations or else any code is having any bug, everything will be manually. They have to check out after all this code. But once the SonarQube has came, with the SonarQube, there are some thousands of rules are available. By implementing those rules, what we can do, we can check the code quality also. Okay. And the next one is once the code quality is tested, then the product will be into the packaging state. So that is building state. I will call it as build state. With the help of, if it is a Java application, we can use the Maven, Gradle, and npm for the node package manager. Like that, there are so many build tools are available. With the help of build tools, we are going to pack the application. We are going to convert that application into an artifact. Whatever the application code is there, that application code can be converted into an artifact. Once it is converted into an artifact, we can store this artifact in the Nexus. So Nexus is an artifact storage, or else you can go with the JFrog also, or else you can go with the Harbor. Okay, or else you can store it in the Git also. So any which ways, or there is a provision to store it in the Jenkins also. Okay, so we can store the artifacts in the Jenkins also. So there are so many ways you can store the artifact, but these are the some of the tools which you can use. And once it is stored in the artifact, then up to here the CI process is completed, continuous integration is completed. Then we have to run this application. Where we need to run the application, that's the primary question that you are going to get. So whenever you are developing an application, there will be, I mean, if the application is getting created, just forget about development. If it is getting created, there will be three stages of running the application. One is in the development environment. There will be development environment, and there will be UAT environment or staging environment. Basically, I will call it as UAT. Some people will call it as pre-prod. Some people will call it as staging. Some people will call it as UAT. So as per your terminology, or as per your company terminology, you can call it, no problem. So among this, the first one is development stage, where whatever the application that is developed, that should be uh, installed on a server and it should be running. And there will be, once the development stage is passed, then you have to go with the testing. I mean user acceptance testing. So once the application is installed on the server, our local testers in the sense, the company whoever are the IT company working in the IT company, they will do the testing. And the application should be submitted to the client, and the client has to accept the application. If there are any bugs, that is found by the client also. They have to do their own testing. That is what user acceptance testing. And finally, we will go into the production environment. So the finally, once the UAT is also done, then the application will be into the live. Live means whatever the end customer is accessing, the application is called as the production application or live application. These are the three different stages or also states that you are having in an application deployment. Now, when the application has to deploy, where it has to be deployed or else where the application has to be installed, either in the development stage or else UAT stage or production stage. Tell me where this application has to be installed. Up to now, is it clear, guys? Whatever we have discussed. Any questions here?
All good, Chaitanya.
Everyone. So is it fine? Are you able to catch my face, or else do you have any problem with my delivery or diction? Can you please tell me about that?
All good, Chaitanya.
We are good.
Good. Now, can you tell me how this application can be deployed or installed? Where we have to install this application? The code is generated in your computers, okay? And then we have pushed the code into the GitHub, which is an web-based interface. GitHub is a web-based centralized repository. We pushed into the GitHub, and we can use the SonarQube and Maven or Nexus. We are using that. So now, how this application will be tested? First of all, how this application will be installed? What are our current requirements?
Chaitanya, we need a pipeline or some manual steps.
Don't go there. So we are not
No,
talking about the pipeline.
from dev, you're going to push it to UAT.
No.
Right?
I am not talking about UAT.
Okay.
Where this
So
application is installed? That's my
in a
question.
container service like a Kubernetes, where it can run, or if it's
Before
pushed
container.
into.
We need to install it on the dev environment in the application server.
Good. So in a server, okay, we'll come back to the containers and all the things. We have to install this application in a server. So these servers in on-premises environment, we will call them as servers. And in AWS environment, they are called EC2 instances. In Azure environment, they are called as Azure VMs, okay, virtual machines. And GCP, they are called as an instances again. So like that, there are different names for that servers. So now, how this server can be created? Okay, if you are working in an on-premises environment, how a server can be created? So first of all, let us go back to some 1995, 1990, 1995 or 2000 era. At that time, how many people know about this Docker? At that time, Docker is not there. Containers are not there. And we don't have this DevOps even. So if you see here, Linux was introduced in the year 1991. And then slowly it got evolved, and Git was introduced in the year 2005. Okay. And then slowly it got evolved, and 2010 the GitHub was introduced. Like that, so many things are happening in 2000, in this millennium only. 2000, 2005, 2010, at that particular time frame only, all these application has came into the picture. So when you see Docker also somewhere near equivalent to 2010. Kubernetes is also in the same time era. So like that, whatever the application that we are discussing, these applications has evolved in the year from the year 2010. Now AWS was introduced in the year 2006, and Azure is also introduced in the year 2010. Now before that 2010, how we used to work? Okay, let us go up to 2005. In 2005, how we used to work with the servers, how we used to work with the application. In 2005, we don't have these many number of applications. Whatever you are seeing right now today, after the internet expansion was happened, because in 2016 they have a huge turn across India related to the internet perspective. When Geo has came into the picture, everything has been changed, and 5G has came into the picture. The speed of the internet has been changed. So now right now in the internet global, what I can say, global village era. So everything is in our fingertips. If you want to pay something, you are having phone pay, GPay, or else there are so many pays has been came into the picture. If you want to book the tickets, movie tickets, you are having Book My Show, District. If you want to book the train tickets, you are having IRCTC, or else bus tickets, you are having Abibus, Redbus. Where all these softwares are there before 2015? We don't have these many number of softwares, this many number of applications. Then in 2015 also we used to have some applications, 2010 or 2005 also. For mailing we are having Gmail, for messaging we are having Yahoo. Okay, so nobody, I think a few people doesn't know about the Yahoo in this session, if I am not wrong. And majorly we used to enjoy, or else we used to do texting from the Yahoo itself. But how this application has been generated? So when you see, before 2005 we used to have the micro, or else the servers inside in our company. So there will be an on-premises environment. Inside this on-premises environment, so if it is a small company, you will have a server room. If it is a top class company like Infosys, HP, or else Wipro, or Microsoft, we used to have the data centers. For example, this is the server room inside the IT company. So in this server room, what we used to have, we will be having a rack, or else we will be having multiple racks. Okay, server racks, we will call it as server racks. So these server racks, inside the server racks, what we will be having? We will be having the multiple, what I can say, networking switches, or also servers, physical servers we used to have inside the server rack. So there will be some physical servers like tower servers, rack servers, blade servers. There will be different kinds of servers depending on the size and shape. We will be having multiple types of servers. And when you come to the networking infrastructure, you will have the routers, firewall, switches. So many different kinds of infrastructure kind of things will be there. So now, if you think this is the server rack, so inside the server, now we want to run the application. Okay, whatever the application that we have created, we want to run this application inside the server. Okay, when we are running the application inside the server, so this is fine. Up to here, if it is a new server and new application, this is good. For example, already we have an application running inside this server. And now the developer has came with a new solution or new upgraded version of application. So the developer is developing an application in his computer with all the required necessary tools. For example, this application is developed on Java 8, 1.8, and this application they are creating on Python or Java 11. For example, this is app 2 version. Okay, or else app 2, second application that has been created in the developer's computer. Now they want to deploy this application. This is an higher, or else this is a new version of application. So here, for example, if you take this application is running in Java, this application is also running in Java. But the main difference is that, so whatever the application 2 is there, this is working with the higher compatibilities, higher plugins, higher dependencies. So the dependencies which are requested, or else which are required for application 1 will not support the dependencies that are required by the application 2. So then what will happen, whether these two applications will run in a single server? Are you understanding my question? So application 1 is created on Java lower version and in this server. So when we have created, or else when we want to install this application, so we need to have the quite a few pre-requirements, like Java is required. If it is a Java application, we require Java. And then we want any another dependencies are there. Maven dependency is there. Inside the Maven dependency, again you need to install some plugins are there. So all the plugins you will be installing. Now, for the instance, if application 2 is developed and this is developed in a higher version of Java. So now I want to run these two applications in a single server. Is it possible?
No, there'll be compatibility issues either or.
There will be compatibility issues. See, in Java, there is an flexibility, like if you are running an higher application, higher version of application, you can run the lower version. But in the beginning, you are running the lower version of Java application. If you want to run the higher version of Java application, there will be a problematic situation, compatibility issues you are going to face. Now for that, what I have to do, I need to use another physical server for this application too. For this app too, I need to use another physical server. So servers are not that cheaper like our cheaper in the sense they are not what I can say, they are costly. So if you want to purchase a server, you have to invest minimum of 3 lakh rupees. So it is not like our laptops which we are going to get for 50,000 to or 60,000. When you want to purchase server, basic server compatibilities and basic server capabilities will be having a cost of somewhere nearly equal to 3 lakh rupees. So 3 lakh rupees per a single server. When we purchase the server, we will be having this, for example, so there will be 8 CPU, and somewhere like some 128 GB of RAM is there. 128 GB of RAM is there. So if you are using a single application, so for a single application, this much amount of CPU and RAM is not required, which means that server is underperforming. So it is not the resources which we are having in the server is not optimistically used. So they are underperforming. So why? Because only one application is running. For one application, 4 CPU, some 32 GB RAM is enough to run all the microservices. That is more than enough. And when you are having this much amount of huge resource compatibilities with the server, all the other resources are wasted. And for running another application, you require another server. That is also becoming an headache or else an issue for the company. So if you want to purchase a server, the first things first, what you have to do. So this is the process. First of all, you have to contact the vendor. The vendor will contact the OEM, original equipment manufacturer. So the OEM has to provide a quotation, and the vendor has to modify the quotation and send us another quotation. Why? Because to get the profit. So this quotation will be submitted to the accounts department. They have to accept it, and the manager has to accept it to purchase the server. Once it is done, then what will happen? Then we will rise and what I can say. Then we will be rising and request to the OEM, and the OEM has to give the server for us. So to transfer the server from the OEM to the original equipment manufacturer to the vendor, and from vendor to the office, it is going to take minimum 2 weeks. Later, what happens? Then we need to do the server hardening. So even it is not installed. Also, whenever we purchase a new computer, new laptop or new server, directly we cannot attach it to the networking. We cannot attach to our company network. What we have to do? First things first, we need to do the server hardening or computer hardening. What is the server hardening? We need to check for any viruses are there inside that. So, sir, without installing the operating system, will there be any viruses? Do you have ever heard about these words? There will be a virus. There will be a hardware virus or boot time virus that are available in the market, which can be injected into the hardware itself. So when you start the hardware, automatically the virus will, what I can say, it will start going bigger and bigger, and it will affect all the other computers also. So there are the viruses. So we need to check the server. We need to do the server hardening, and then we have to connect the server to the, and then we have to apply these ports should be open, these ports should not be open. Everything we have to check it out, and then we need to connect the server to the network, and then only we can use the server. So this much amount of things we have to check before the server was into the network. And later, once the server is into the network, then we have to do the maintenance, like monitoring the server, managing the server, checking out how much amount of disk is utilized, how much amount of CPU, how much amount of RAM is getting utilized for a single application, what is the problems, what are the bugs, at what time there is a spike in the resource consumption. Everything we have to monitor it. So this is also becoming a very hectic problem. So now what the IT industry has done here is, uh, because of all these conditions, so they have introduced a new concept called as virtualization. Okay, virtualization. What is this virtualization? Virtualization is a platform where you can divide a single physical server into a multiple logical missions. So I purchased a server. My server is having some 16 CPU. So the server is having 16 CPU, some 164 GB of RAM or else 128 GB of RAM. For example, let me show you something. Okay. So this is the, just assume that this is the server which I have purchased, which is having 8 CPU and 32 GB of RAM. So inside this 8 CPU, 32 GB of RAM server, what I want to do here is, I want to create some virtual missions. So I can create the virtual mission. So here I have installed the VMware. Just assume that this is the server which I have, server hardware which I have purchased. Inside that, what I am going to do here is, I am going to install the VMware ESXi or else hypervisor or Citrix. There are so many softwares that are available in the market. So I am going to use the VMware. So VMware ESXi. So this is the software which I am using. Previously, I used to tell this classes also, but anyways, so this VMware ESXi software I am going to use. And with the help of this application or else with the, on top of this, what I'm going to do, I am going to run my servers. Okay, so if you see here, I am having the Kubernetes cluster which I have created. This is the master node, worker node 1, worker node 2, just for my testing purpose. So all these three servers are my Ubuntu servers only. So where I have created these servers, I created these servers inside the hardware, server hardware. I have installed the VMware. Inside the VMware, what I have done here is, I created 3 Ubuntu missions. So this is my master node for my Kubernetes cluster. And there is another node which I have created here. This is my worker node 1, worker node 2. So like that, I have created 3 servers. And if you see the server capacity, so what is the size of the master node? So if you see the master node, 4 CPU, 8 GB of RAM. And if you see the worker node, it is 2 CPU, 4 GB of RAM. And if you see the node 2, it is also 2 CPU, 4 GB of RAM. So total how much amount of RAM that these servers are consuming means 16 GB of RAM from my physical server. So whatever the physical server that I am having from my physical server, each server is consuming some amount of RAM. So that what will be happening here, the resources will be optimizedly used. Previously, what is happening for a single application, we need to have a single server. But now what is happening? Whenever the virtualization was introduced, with the help of virtualization, what we can do here is we can divide a single physical server into a multiple logical missions, logical virtual machines, and into that we can install whatever the application that we want. For example, if I want to create another server, I can create another server. For example, I want to create an Jenkins server, or else I want to create a SonarQube server. What I can do here, I can go with the app server. I want to create an app server. So, and I can go with the Linux family, and the operating system is Ubuntu operating system. Next. And what I can do, here I can provide the CPU, how much amount of CPU I want, how much amount of RAM I want. I can provide that. And then hard disk is thin provisioning. So there is a concept of thin provisioning. And then what I can do, I want to install the Ubuntu operating system on my server. So I can install the Ubuntu operating system on this app server. So if you want to increase the hard disk size also, you can increase the hard disk size. So right now, what is the hard disk size? It is 25 GB. I can make it to 50 GB. Let me make it as 50 GB. And then I can power on, I can install the application, or else I can install the operating system on the server. And I can use this application server just like our physical server only. So this is the main benefit with the virtualization. So virtualization made very, very comfortable in the IT industry. Right now, whatever the servers or else whatever the applications that you are seeing, all the applications are running inside the virtual servers only. And the cloud environment, whatever the cloud that we are talking, AWS, Azure, or GCP, so the main base for this entire cloud environment is the virtualization only. Whatever the EC2 instances, VMs, Azure virtual machines, or GCP instances, all these servers are running in the virtualization platform. They are the virtual machines only. So now how right now I am creating the virtual machine in the same manner. We can have the virtual servers in the cloud environment or else in the on-premises environment also. We will be purchasing the server, and this server will be divided into the logical machines called as virtual machines. And inside this virtual machines, what I can do, I can install whatever the application that I want. So that what will happen, these applications will be optimizedly, so they will be running more effectively, how much amount of resources they want. They will communicate with the virtual machines, and virtual machines with the help of VMware, they will get from the physical server. So like that, the virtualization will be helpful. This type of virtualization is called as bare metal virtualization. Bare metal virtualization or type 1 hypervisor. I will call it as type 1 hypervisor. So what is bare metal means? So here you can see the virtualization software is directly installed on the server hardware. So we don't have any intermediate operating system like Windows or Linux. Directly the virtualization software is installed on the physical hardware, and we are able to access that virtualization software through the browser, and we are installing the required whatever the required softwares or else required operating system is there, that we are installing over here. So this is about the configuration. So I will simply give like app server and then Chaitanya. Okay, done. Done. So it will install the required operating system in my computer. We'll come back to that later, but that is how you can create your virtual servers. And inside the virtual servers, what you can do, you can run your applications. So this is how the servers will be optimizedly used. And then these are the basic references to your, what I can say, your cloud environment. Okay. So like EC2 or VMs, any cloud environment, if you want to have a server, so the virtualization is the primary platform. And major number of cloud platforms will have their own virtualization. So this type of virtualization is called as bare metal virtualization. And the second type of virtualization is there. So where you will have the hardware. This is the client side virtualization. So now whatever you are seeing here, this is the main server virtualization. This is the client side virtualization. You will have the physical hardware. On top of that, we will be installing an operating system. Just like this, I'm having my computer. Inside the computer, I install my Windows operating system. Inside that, I am going to use the VMware Workstation Pro. So that is my client side virtualization software. So inside that, what I can do here is I can create the VMs. So this is called as hosted virtualization. So the main difference between the bare metal and the hosted virtualization is that you will be having the operating system in the middle layer. So but in the bare metal virtualization, you won't find the operating system. So this is the main difference between the hosted and bare metal virtualization. Hardware, and there will be a virtualization software like VMware, or there will be a KVM, kernel based virtual machines for the Linux environment. And if you want, you can go with VBox, VirtualBox, like that. So there are so many client side virtualization platforms are available. And then we are having the VMs here, and inside the VMs we can run the applications. And this is called as type 2 hypervisor, or I can call it as type 2 hypervisor, or I can call it as hosted virtualization. So these two are the hardware virtualization. Whatever you are seeing here, these two are the hardware virtualization. Now, when we go in deep into that, now when you come back to the 2015, we have a software virtualization channel or a software virtualization application that is called
Chaitanya,
as
what is the difference between that type 1 and type 2? Type 1, we have a physical server and VMware, and we are deploying the server application servers. The type 2,
type 2, there will be hardware and there will be an
okay,
operating system. Did I say operating system in type 1? In type 1,
okay, no,
what is there? Yeah. So
type
in
1,
type 2,
type,
hmm,
there is operating system.
in type 2, you
Okay,
will have the operating system. Okay. In type 1, we
okay,
don't find any operating. That is what I said. So if you see this virtual server, or else if you see this server, Inside the server, when I create that, directly I am having the VMware ESXi implemented on that. I don't have any physical, I don't have any operating system. So this is the type 1 virtualization. Type 2 virtualization means we have an operating system. Inside that, we are going to install the VMware software or else a virtual box. With the help of that virtual box, we can run the applications. So that is a type 2. So companies will not use the type 2. Just for our understanding, we can use the type 2 operating system, type 2 virtualization. But majorly, the companies will be using the bare metal virtualization. Okay. And the next one is software virtualization has came into the picture, nothing but the Docker. Docker or else containerization. So we will discuss about this Docker and containerization in deeply when we go into the process. Now here you can see there are so many ways to create the servers. Either you can create the servers manually or else you can automate the server creation. How we are going to automate that we will see. Now up to now it is clear now. So if I want to install an application, we need to have a server. So if you want to have a server, either you can have a physical server or else you can have a virtual server. In now today's in this generation, whoever are working in the on-premises environment, they will be using the virtual machines only. So now how these servers are getting created, how we can create the servers. Now if you see, I manually created the server here. If you can see here, I have manually created the server. The server installation is completed. Then what I can do here, so if you see, I will be logging into my server. So simply, so the manual installation I have done here. So how I am accessing that server? So through putty or else there are some remote tools that can be helpful for me to access this particular server. Excuse me. Sorry. So if I want to access this server, there are some tools like putty or else I can use the PowerShell or there are some mobile extreme like that. There are the applications. With the help of these applications, we can access the server. So up to now, whatever we have discussed, that we discussed about the installing the servers. So this can be automated or else this can be, these servers can be created with the help of code. So we don't need to create all these servers physically. So we don't need to log in into the console. We don't need to select the operating system. Automatically, you can create the server. How we can create the servers automatically or else how we can create that? We can create them with the help of a code. That is what we call it as infra as a code. Infra as a code. So infrastructure as a code. So this will be achieved with the help of Terraform. So Terraform is a tool which will be creating the infrastructure with the code. We have to write the code and with the help of the code, it will create the infrastructure. So now how in which cloud or else what are the preferable or else compatible infrastructure provisioners here means Terraform can create the infrastructure in the on-premises environment with the virtualization. The Terraform can be compatible. So it has its own what I can say plugins available for the virtualization deployment, and for AWS environment you can use the Terraform. For AWS, you can use Terraform. For Azure, you can use the Terraform, and as well as for creating the Azure infrastructure, you can use the Terraform, and for GCP also you can use any cloud, you can use the Terraform, and as well as on the on-premises, you can use for the virtualization only. So Terraform is a third-party tool which is developed by HashiCorp. So there is a company called as HashiCorp. Okay, they have developed this Terraform. Not only that, they have the HashiCorp Vault is available, HashiCorp, what I can say, Packer is available. There are different kinds of tools are available, and they have introduced an orchestration platform. Like Kubernetes, this HashiCorp is having another orchestration platform called as Nomad. So this is also one of the orchestration tools like Kubernetes they have introduced. But anyways, so do we have any separate tools to create the infrastructure? So like Terraform, yes, for every cloud you are having a separate tool. For AWS, there are cloud formation templates are available, CF templates, cloud formation templates. And for Azure, there are ARM templates are available. ARM means Azure Resource Manager, or else management templates are available. And for GCP also, you will be having a separate configuration. So like that, for every cloud itself, or else the cloud itself will have its own infrastructure provisioning softwares, or else provisioning resources are available, like cloud formation or else ARM templates. But if I want to switch between the multiple clouds, we cannot do that. So with the cloud formation templates, I can use the AWS environment tool. I can use in the AWS environment. ARM templates I can use in the Azure environment, but I want to go for the multi-cloud environment. So in that cases, what you can do here is you can use the Terraform. Terraform is an tool which can be compatible with any cloud, and we can create the infrastructure in any cloud. With the code, whatever the code that we are writing, so within a single Terraform code, you can use the multi-cloud environment also. That can be also possible. So any which ways, the point is Terraform has become a very, very crucial and vital role for creating the infrastructure. Okay. Now that is about your Terraform. So this is the introduction to your server, how we are going to create the servers with the help of Terraform, and where the Terraform is compatible, and how we can we did not discuss how we can configure it. Right. So now, and then what we can do, once the server is created, we can run the application inside the server, and we can get the logs, and we can monitor the application. So this is entirely called as a CD process, continuous delivery or continuous deployment. So in without server, or also I don't want the server to be there. So why? Because server is having its own compatibility issues, its own environmental issues. I don't want that to be affecting my application. So simple example is that, for example, you cook very well. Okay, the students who are attending to this session, I hope that the students cook very well. For example, if you are preparing some food, okay, for your friends, I will tell you about the prerequisites, Kalyan. Okay, so if there are any master chefs are there in this session, so I just want to ask you a question. So you prepared so you got some promotion in your office, and you have invited all your friends to your home. All of your friends, or also all of your colleagues has came to your home, and you prepared some or also you prepared some dish for your friends. Now all the friends liked it, and one of the friends says that okay, I like your food very well. I can cook the food. So can you please give me the recipe? So you provided the recipe to your friend. So when you provide the recipe to your friend, whatever the dish that you have prepared in your environment or else in your kitchen, will, if you provide the recipe, will that be replicated same as it is, how the taste and how the texture that you have prepared when your friend is preparing the same food, or else when he is cooking the same dish, whether it is going to be replicated as it is, or else is there will be any changes in the flavor, or else in the taste or in the texture? How it will be? You prepared the food, it has came very well. Okay, the food taste, food color, food texture, everything is good. But when you give the recipe to your friend, when your friend is trying to cook the same with the help of same recipe, will it be the same, or else is it going to be any changes will be there? Do you understand the question what I asked?
Yeah, yes, little bit changes will be there because we do not know what kind of mixture masala things he is using. So maybe little bit changes. Base thing he used that recipe,
Mm-hmm.
but we cannot say exactly the taste will be.
So we cannot say that the exact taste will be coming. Okay, so now in such cases, okay, when I come back to the application perspective, you created an application. So in your computer, the application is working very well. Why? Because in your computer, whatever the application, whatever the dependencies that you want for the application, you have created all the dependencies, and your computer supports it. So if you give the same application code to your friend, he has to run in his computer. Whether the code will be running same as it is how it ran in your computer, or else how this application has created and running in your computer, in the same way the application will be running in your friend's computer also. Is it possible? Go on, guys. I hope you understand the question. If you don't understand, I will repeat it again.
No, we understand because he maybe has some different CPU, different memory. He has some different.
So it's not,
It's
I'm
not
talking
exactly
about
run.
the, software dependencies may be different. So then what you will say, it is running in my computer. So the same way, if you want that application to be running in the Linux environment inside the servers, it will have its own compatibility issues. So that is what we are calling it as. Runs in my computer. It is not running in the server. So actually the application has to run in the server only. Why? Because the entire life of the application will be, spending inside the server only, no? So this application has to run inside the server. If you say the application is running in my computer, we cannot expose the computer directly to the end customers. So now there is a problem here. So how I can overcome all these environmental issues? These are all the environmental issues. So if you create the application in your computer, so that's your personal environment in which you are having the softwares, dependencies and everything. But the same environment I cannot replicate on the server. Why? Because inside the server already a few applications may be running. So I don't want any dependent platform, just like I don't want to install the application on the server. So then what I have to do? So then the IT companies has came with a solution called as Docker. So it is a completely server independent or else platform independent. You can create any platform with the containers and you can run the application with all the dependencies. So containerization has evolved now, and then what happened? The containers are created and multiple applications are running inside the containers, and these containers are managed by the orchestration platform like Kubernetes. Whatever the Kubernetes that we are discussing, these Kubernetes will be helpful for running those, managing those containers. So for containerization, we are having the Docker. So here we are studying about the containers. So not about the Docker. Docker is just a platform. Okay, just like your Google Chrome, Docker is also a platform. In Google Chrome, we are going to open multiple applications in the new tabs. So those are like containers. For example, if I open the Google Chrome, so here I am having VMware ESXi. I can open the cloud application. I can open somewhere like Jenkins application if it is available. So what is the underlying software? The underlying software is Chrome. On Chrome, what we are doing, we are opening the multiple applications. In the same manner, for containerization only, for containerization also, we are going to use an underlying software like Docker or else RKT, Containerd, or what else I can say, Podman for the Red Hat Linux. So these are all the underlying platforms to run your containers, where actual applications will be running. Actually, the applications will be running inside the containers. So if you understand about the containers, then you will understand how the containers will be running, how applications will be running inside the containers. On top of that, we will be learning about the Docker also. So majorly we will be working on the containerization. Majorly we will working on the containers. The most important thing is that, and how we can manage these containers. So that can be learned in the orchestration platform. So there are so many orchestration tools that are available like Docker Swarm, Kubernetes, OpenShift, Nomad. Like that, you are having so many different kinds of orchestration platforms are also available. Among those orchestration platforms, we are going to discuss about the Kubernetes. So that is about the basic introduction to the course. What is this course, and why we are learning this course for understanding the continuous delivery and continuous deployment. We will be learning this course, and with the completion of this course, you can apply for the jobs which are requesting to have a mandatory experience in the Terraform, Docker, and Kubernetes. You can apply for that. And what will be covered in this course? I am not going to give you the complete syllabus. You can see in the durgasoftonline.com. You have the syllabus available over there. But anyway, we are going to cover the Terraform. In Terraform, we will be discussing about the Terraform basics, Terraform functions, Terraform modules, Terraform workspaces. And I want to introduce Terraform Vault also. Okay, or else HashiCorp Vault also I want to introduce. Let's see. And finally, we will be working on the Docker. So in Docker, we will be working with Docker introduction, Docker basics, Docker lifecycle, container lifecycle. Those are all comes under the Docker basics, and Docker images, how we can create a Docker image with the help of Docker file, how we can create the image manually, how we can create the image. And then we will be discussing about Docker volumes and Docker compose and Docker swarm. And then we will be going into the Kubernetes. In Kubernetes, there are so many topics to cover. So like coming to the understanding the microservices versus monolithic applications, and then understanding the Kubernetes architecture, creating the Kubernetes with the kubeadm, kops, rancher, and then AWS EKS cluster we are going to deploy over there. And we will be working on the workload components like pods, deployments, replica sets, daemon sets, stateful sets, and then services like cluster IP, headless services, node port, load balancer services, external name services, and then sidecar containers. So these are all the things that we are going to cover. Sidecar containers, namespaces, resource quotas, and what else? What else I am missing? Probes. Okay, advanced scheduling, node affinity, pod anti-affinity, and then node selector, taints and tolerations, and storage configuration, persistent volume claims, EFS configuration with the help of Kubernetes. And then we will be discussing about the Helm chart, STO service mesh, and monitoring tools. All are going to be covered inside this session. And finally, we will be working on Jenkins. So basic Jenkins configuration, high availability of Jenkins, and then how to add the node in the Jenkins and how to monitor that, and everything. So how we have to design the CI/CD pipelining tool, what is meant by freestyle configuration of Jenkins, and the pipeline configuration in Jenkins, multi-branch pipeline in Jenkins. So these are all the things that we are going to cover in the Jenkins. So this is the basic introduction towards your entire course. So that's it. That is about the course which we are going to cover in this sessions. Okay. And one more thing, the last and final thing that which I want to give here is the session timings will be at 7 a.m. in the morning. 7 a.m. Sorry. 7 to it might be 8:15 or 8:30. Right now the time is 8:17. It might be prolonged up to 8:30 a.m. also. No holidays, guys. No week offs, no weekends. Okay, every day you will have the session. Okay. Every day you will have the session, and most probably only one Saturday and Sunday you can get an off, but eventually you will have the sessions on every day, and the course will be completed within 30 days. We are planning the course to be completed within 30 days, and if not, it might be taking some 35 days or so, plus or minus 35 classes, 35 hours. Okay, take like hours calculation, and then you will get the documentation, and then you will get the videos related to the course. And what else I am missing? Pre-requirements. So AWS understanding, have a basic understanding towards AWS is necessary. Sir, I am very much connected to Azure. No problem. Any cloud is okay for me. Okay, either if you are working in AWS or Azure, no problem. You can work with any cloud. So yeah, that is the basic pre-requirement for learning this course. Apart from this, we don't have any pre-requirements. You need to have a laptop with a good internet connection to attend the live demos and live sessions, and as well as you need to have the putty installed in your laptop. That is the only requirement from my end, and rest of the things, okay, no problem. Okay, so that is about the basic introduction towards your course, and what are the pre-requirements and what we are going to cover in this entire course and how we are going to cover. So I have clearly explained you about those things. I hope you understand this. Any questions? I gave you the prerequisites. What are the prerequisites? Harsh Chauhan or Harsh Sharma, anyone? What are the prerequisites? No, I won't cover GCP.
Internet and laptop mainly.
AWS, we will be covering the AWS environment completely. Okay, if you cover the AWS environment, the rest of the environments are also the same. Yeah. Okay. Anything else, guys? Yeah. Am I clear with the entire concept, or do you have any questions related to this concept? Why we are using the Terraform? Why we need to go for the Docker, Kubernetes, and Jenkins? Any questions from that? Is the classes? I mean, are you able to understand the class clearly? Do you have anything else to ask? You can ask me right now. Questions? Yeah.
What functions we use in AWS?
Sorry.
In AWS.
Resources we will be using EC2 resources, load balancers, VPC, IAM roles. These are the things that we are going to cover.
In case if I replicate that in other cloud like Oracle Cloud, is it possible?
Yeah, the only thing is the difference. Resource names will be the difference. Apart from that, everything will be the same, most probably. Okay, if you go with the Terraform, in Terraform, for example, Terraform Oracle Cloud Provider. Okay, so if you see here, I am also going to tell from this documentation only, no problem, don't worry. So if you see here, install the provider, or else what I can say, I'll go with provider.tf, like kind of things. Okay, for the Oracle Cloud also, we'll have the same thing. Oracle Cloud Infrastructure, required keys and OICD, and installing HashiCorp, and then you can have the Terraform. We will be installing the Terraform. So we have to configure the provider. So how we can configure the provider? You need to have the authentication key and then the region, and you have to give the provider OCI. So in AWS, we will provide the provider as Terraform AWS provider. If you see here, what is the Terraform AWS provider here for Terraform? Provider AWS. In Oracle, what is the provider? Provider OCI. And authentication. Here we don't provide the authentication in AWS. We will be configuring as an environmental variables. That is altogether a different thing. And the region. So in which region you want to create the infrastructure. Here also you are going to provide the region. Both are the same. Only a few things will be changing from one cloud to the another cloud environment. The names will be, especially the names will be changing. Okay. Apart from that, everything is same.
Okay.
Got it? Anything else, guys?
Chaitanya, how the means Ansible, what will be, we can say that is the difference between Ansible and Terraform.
Ansible is for the configuration management tool. It's a configuration application management tool. See, let me give you an example. So you want a job. Okay. So when you apply for the job, the interviewer will interview you and you will be appointed for the job. Okay. So Terraform is also like the same. So it will create the infrastructure. So how HR is appointing you into the job, Terraform is also provides the what I can say, it will provide the infrastructure for you. Now, who has to train you? Who has to do the configuration for you? Training is nothing but the configuration only, making understandable towards the project and what are the basic things that you know. So that will be given by the manager itself. So in the same manner, Ansible is for example, I am having 10 servers. I want to install Java in all the 10 servers. Just an example I'm saying. So if you want to install Java in all 10 servers, how you will be installing Java in 10 servers? Server by server, you are going to install the application. How you will be installing that? First of all, you need to log in into the server, and then you have to install you need to update the repositories, and then you have to install Java. Minimum, it will take some 3 minutes to install Java on one server. For example, if you want to install on 10 servers, how much amount of time you are going to put on installing Java in 10 servers? 30 minutes. For installing Java itself, you are taking 30 minutes means. Then for installing all the other dependencies, it will take some 1 hour to 2 hours, where there will be a lots of time dependency, time wastage will be there. So to overcome this problem, what I'm going to do here is I will create an Ansible server and I will add all the servers to that Ansible host and I will install the applications without wasting the time. Simply I can do the automation of installing the applications onto our servers. You can use Ansible as and Terraform also. You can create the infrastructure with the Ansible also. But the recommended process of installing the infrastructure is through the infrastructure as a code. We have a separate tool for that. Then why we need to use the Ansible? Okay. So Ansible is for the configuration management. Terraform is for the infrastructure provisioning. Okay.
Thank you.
Good.
Here the Terraform used to give the configuration how the infrastructure is used.
How we can deploy the infrastructure, how we can create the servers,
Yeah.
how we can work with the cloud environment. So when you take a cloud environment, you have to create the VPC subnet. If you go for the Azure also, there will be resource group and VNets, subnets, and then you have to configure the security groups, firewalls. When you come back to the AWS environment, VPC, subnets, routing tables, security groups, and EC2 instances, all this will be declared in the Terraform. Okay. You got it? Still you have the questions. Yeah, Ramesh, tell me.
Yeah, sure, understand.
Good. Anything else, guys? Okay then.
In case
So,
if we miss the class, is there any possible you can get that recording session?
what is this? You are going to get the documents and videos.
Okay. Okay, fine.
Okay. So that's it from mine. Have a nice day, and we'll meet in the tomorrow session and discuss more on starting. We will be starting the Terraform directly. So there is no repetition. See, one thing that I want to clearly make sure that my sessions are all of two-way communication. It's not like a radio communication. I don't want to sit quietly and I don't want to ask you all the things. So it's a two-way communication. That's the first one. And the second thing is that so for me, it's not like demo from day one, day zero. From today onwards, your course has been started. If you join or not joining, so that totally depends on your understandability. Okay. So my course has been started. Okay. So from tomorrow onwards, it's not another demo like I have to repeat the entire concept and again and again. I'm not going to do that. So from tomorrow, we will start working on Terraform and understanding the basic compatibilities and how we can create the Terraform and all the things. Okay. So yeah. So that's it from mine. Have a nice day and we'll meet in the next session, guys. Bye. Thank you all.
Thank you. Thank you.